Dr.M.G.R.Educational and Research Institute, University, Madurai, Chennai. Dr.M.G.R.Educational and Research Institute, University, Madurai, Chennai.
Anyone is old, whether at 20 or 80. Anyone who keeps learning stays. Hello? Ma'am, live போயிட்டு இருக்கு மேம், ஒரே நிமிஷம்.
Dr.M.G.R.Educational and Research Institute, University, Madurai, Chennai.
Anyone who stops learning is old, whether at 20 or 80. Anyone who keeps learning stays young. The greatest thing in life is to keep your mind young, said by Henry Ford. With this saying, a very good and warm afternoon to everyone who assembled here. I am R. Nandini Devi, Assistant Professor, Department of Mathematics, Phase 2, Adyalampattu campus, shall be your host of the day. It is my great pleasure and the first and foremost duty on behalf of Department of Statistics, Department of Mathematics, Dr.M.G.R.Educational and Research Institute, Phase 2, Adyalampattu campus, we warmly welcome you all to this beautiful program, a 2-day national level e-workshop on programming statistical data analysis using MS Excel. On the first day of the event, the session was beautifully handled by our chief guest, Dr.M.Venkateshwaran, which was highly informative and beneficial to the young researchers. The new dimension of statistical data analysis was clearly demonstrated and delivered impressively by our chief guest. Today is the second day of our program, and I assure you that today's session will be highly informative, which will let you to gain practical knowledge on statistical data analysis. Dear participants, the feedback form will be available in description box at the end of the session. Now, I would like to call upon Dr. R. Nagaratnam, HOD in charge, Department of Mathematics, to formally welcome the gathering.
A very good afternoon to one and all present here. I welcome you all for the second day of National Level E-Workshop on performing statistical analysis using MS Excel. Yesterday's session was wonderful and beneficial. I hope that all of you have enjoyed the session and gained the knowledge about statistical analysis using MS Excel. At the outset, I express my gratitude to our beloved Founder Chancellor A.C. Shanmugam and our beloved President, Engineer A.C.S. Arunkumar, for allowing us to conduct such useful workshop for students and faculty community on the whole. I place upon a special welcome to our Joint Registrar, Dr. S. Ramalingam, our Dean, Dr. S. Manivannan, and Deputy Dean Dr. V.N. of Phase 2 campus for the pillars of great support for us and to the entire campus as well. I wish to thank our resource person, Dr. M. Venkateshwaran, for his informative session and welcome to the second day of the workshop. I am immensely happy to welcome Dr. Johnson, HOD, Department of Mathematics, Dr.M.G.R. Educational Research Institute, and my dear staffs in our department. And also, I am very happy to welcome all the HODs of other various departments in our university. Last but least, I welcome you all from the various institutions in all over our country, India. Thank you. Thank you so much.
Now, I would like to invite Dr. V.N.Rajavaran, Deputy Dean, Phase 2 Adyalampattu campus, to deliver a felicitation address.
Good afternoon to one and all. First of all, I would like to thanks to the resource person of this wonderful workshop, Dr. M. Venkateshwaran. On behalf of our Dr.M.G.R.Educational Research Institute, management, and the young and eminent personality of our President ACS Arun Kumar Sir, for coming and accepting our invitation and joining here. Really very much proud about the Department of Mathematics for organizing this excellent national level workshop. Particularly, I wish the department head, Dr. Nagaratnam Madam, and the department faculty. I really thank you. Also, I wish Mrs. Srisha and Nandini for helping in the level of giving technical support and campaigning, and I wish all the faculties. I think this is the more useful and very knowledgeable workshop, and also you are conducting in right time. I hope you are getting more knowledge and aware on this topic of statistical data analysis using MS Excel. I'm very happy. Once again, I wish all of you to success this workshop in grand manner. Thank you, one and all.
Thank you, sir. We feel honored to have with us the Honorable Chief Guest, Dr. M. Venkateshwaran, Associate Professor, Department of SNH, SV Engineering College, Tirupathi. I humbly request our Chief Guest to share his knowledge with us.
Okay, good afternoon to all of you. Once again, I would like to express my thanks to Dr. M.G.R. University, the authorities, and the faculty member for giving me this great opportunity to share my knowledge in this online platform. Yesterday, we have been went with the discussion of basic statistics, then correlation and regression. So, with this extension, we can go on with the next, that is towards the next level of presentation. So, with this note, I'll go for my presenting my screen here. Okay. So I've been entered into the day 2 of this e-workshop here. So yesterday in the day 1, just we went with the formal topics. Just I want to recall what have been covered there. We had a discussion on data and statistics. Similarly, with data collection, data types, and how can you present your data, that is in visually or in numerically, that is measures of central tendency, dispersion. The nature of the data has been discussed there. There is the skewness and kurtosis, how the data has to be. Similarly, how to perform your correlation and regression in MS Excel. So these are all the things we have been discussed in the day one yesterday. Now in day two, we can go with the topic of hypothesis. It is testing of hypothesis. So before going to these testing of hypotheses, I want to make you familiarize with some basic concepts here. So with these terms, you can understand what you are going for. That is, it may be an basic definitions, or you can call it as an terms which you are using in the problem. So if you are familiar with these terms, so when studying a problem or when analyzing a problem, or if you are presenting a particular problem, you can understand clearly. So here in this second day class, my view to present on what are the concepts we have been covering here. So then we are going for what are the data sets. Similarly, what will be the analysis in the Excel. We will be having a classification in three different cases here. So first of all, going for the hypothesis, why we need to go for testing of hypothesis? What will be the basic need? So first you need to understand the particular nature here. Earlier in the last class, we have been went on up to regression, that is basic statistics. Then we went with the correlation and regression. So up to here, we are all discussing the total data set. So whatever the data set has been given, you are using the all the data set. It may be 100 in number, it may be 1000 in number. You are using all the data set as it is. With that, you are performing the analysis. It may be correlation, it may be regression, or it may be simply a mean, median, mode, whatever it is. Now here in the testing of hypothesis part, you will be going with the part of your data. You are not going for the total. So that's what you are specifying with the term called here population. Similarly, sample. So population here it represents that it is nothing but the collection of objects regarding a particular problem. So don't remind about that the population will be applicable for only a people. There is a population of India or population of America particular. Don't link it with the person here. So here you have to go for a population of, it may be a living or it may be a non-living. In both the cases, we will be going for the population case. That is nothing but the total. I have given you some examples here. The total number of patients affected by COVID-19 or all engineering colleges in Andhra Pradesh. Total, if you have been going for that, you are calling it as in the population. Whereas the sample itself represents that it is a smaller part, or you can call it as a finite subset from your population, where you can call it as a sample. So in the about two examples I have been given with all engineering colleges in Andhra Pradesh. Now I am making it as a sample here. Number of engineering colleges in Tirupathi. I am making as a sample. Similarly, total number of patients is the total population, whereas coming over here, number of patients affected by COVID-19 in specific region. So if you have been going with a particular specific region, I am calling it as a sample. So here the sample size has been classified as in two cases, large sample and small sample. That is with the number. If it is more than 30, you are calling it as a large. If it is less than, you are calling it as a small sample. So why we need to go for the sample size as large and small? Generally the sample itself, it is a small quantity. That is a finite part from the population. Then why you have to specify particularly large and small sample? The main reason for that is, if you're going for testing a particular problem, let us if I'm going for a quality analyzation. In quality analyzation, I may be facing with different problems. Let us, if you're having a analyzation of let it be some water bottles has been prepared in a particular company. Suppose if you are seeing those water bottles, you have to verify whether it is a quality one or not. Generally, you know that while verifying for the quality, so the particular product will be used for different cases. They'll be checking with the damage levels, they'll be checking with the breakable levels. So then the particular product may not be reused again. So in the bottle cases, the bottle cost may be hardly 20 to 30 rupees, or depends upon the quality, it may be changed 40, 50 rupees. If I'm testing for 10 bottles, let it be. So each bottle costs 50 rupees. So then 500 rupees cannot be reused again. That is that the 10 bottles. In those cases, it is clear. Suppose if you are going for an large, that is, if you are going for an the one item which is having a more value. Let us again think about a bike or maybe a car. So the car will be tested for an quality. As you know that in the cars you will be having an air balloons. So they will be checking with that when the car is met with an accident, the air balloons will be automatically came over to the particular persons. So to test that, they have to make some practices. So they will be checking within the speed levels. Similarly, they will be making within. They have to check whether the air balloon is working properly or not. So for that part, they have to do with some quality checks. So in those cases, again, if they are going for an cars, they cannot go with a more number. They cannot go with an 10 or they cannot go with an 100 cars. So they will be going with a very lesser number, 1 or 2 or 3 at the maximum. So that's what the sample size has been classified here. There is a small sample and large sample. Simply can also say that if you go for a blood test, you are going for a blood test, you're giving a blood sample as an 5 ml or 10 ml the maximum. You cannot go for a blood test for 1 liter or 2 liters. So that is a simple case here. The reason for classifying as in small and large is the main peculiar part here. So whether you have to go for a large number of count or whether you have to go for a small number of count, that's what they have been classified. So 30 is a scientific number that it will be representing that large and small sample. When if you have been entering into the population and sample, you need to remind about some parameter, that is parameter and statistic. So again, we are having the concept called mean, variance and standard deviation. So these three will play a major role. So again, why these three only again? So if I am having a population set as 1 lakh, or I may be having a population count as 10,000, or it may be an 10 lakhs. Similarly, if I go for the part of a population, that is a subset. In the sample cases also, I may be having a number of samples. It may be 10 samples, it may be 100 samples, it may be 500 samples. It depends. So if you're going for these number of samples and population, you cannot go through each and every sample at a time. So you cannot go within quality. You need to have some consolidation again. So let us, if you are going for an chalk piece quality, what is the length of the chalk piece? So let us, I'm selecting some 100 chalk pieces as sample. So I can calculate each and every chalk piece length. So I cannot go with each and every verification. I need to have some consolidated data. So for that part, I will give an average. That is the average height of the chalk pieces. So it may be a population or it may be the sample. So that you are going for these particular parameters, mean, variance and standard deviation. So the dispersion part will speaks about your quality variations, how it has been varying. As you know that when you are going for an mean, so the mean will be a common cases here, but coming out to the variance and the standard deviation, if you are going with that, there will be having a dispersion, how it has been varying from the actual data. Here the sample mean, sample variance, sample standard deviation, those three can be calculated that way. Whereas we have been given with the samples, that is you may be given with 30 samples or 50 samples or 100 samples. With that you can calculate the mean, variance or standard deviation. You can use the formula, you can use the Excel, or you can use any other software tool and you can calculate. But coming to the population mean, population variance, population standard deviation, it is defined as in two different cases here. You cannot go with an each and every number. Sometimes it will be called as an predefined values, where some will be using it as an gold standard values. So as you know that if you're going for an checking of fever, that is a body temperature, so the common number is said that 98 degrees will be the normal temperature. So if it is lesser to the 98 or more than to the 98, automatically you're calling it as a fever. So then how the number has been arrived 98 in a medical terminology, so where you are calling it as some standard value. So we can't say that each and every people's temperature has been calculated then made an average. It is not like that. It has been a study. With that study they have been given a value. Similarly, if you go for an blood pressure levels, you have been given with an 80 by 120. So the numbers has been arrived as an gold standard values. With that will be proceeding. So which will be fixed as an parameters, or you can call them as a population parameter. So to check whether it is right or wrong, you can go with the testing procedures. Next, actually yesterday we had a question from a participant regarding the determination of sample size. Normally, if you go for an sample size determination, they will be having a different perceptions. So some may be having that 5% of the population size will be the sample, or 10% of the population size will be the sample. Let us, you're having a population of 1,000, I can go within 10%, or I can go within 5%. Some may be having an decisions. But theoretically, we have been derived with a formula as that samples in the most of the cases we'll be discussing in sample size, as here you can see n equal to zs by e whole square. So that is, z will be the standardized value, so corresponding to the confidence level of 95%. There is a z is nothing but your z test table value. So with that table value you can obtain 95% will be your confidence limits. So here that confidence limit value, so if I am going for any survey or any problem, automatically you may be thinking about that. You cannot say that my particular problem or particular survey will get succeeded as 100%. So no one can assess that 100%. As you can see in any advertisements, they'll be saying with them that 99.9% the particular problem will be cleared by using the particular product. They'll be giving a hand. They cannot make sure that it is a 100%. So some variation, some error will be will be happening generally. Here, in these conference cases, we have been classifying as in three standard cases generally. That is 95%, 99%, similarly 90%. These three are the standard confidence intervals. That is, you have been specifying that 90% confident that the particular survey or the particular problem will be exact. 95, similarly 99. But in the real-time problem, you have to change your numbers. You cannot go with the same standard. It may be changed. It may be 85, it may be 93, it may be 87. You can go with the different percentages here. So remaining cases, that is if you're going for 95, 99, 90, so what about the balance percentages? If you're 95, so the balance will be so that is 5 or 10 or 1, you are saying it is an errors, that is acceptable error alpha. So with these two cases we can calculate. One more thing here, the sample standard deviation from the pilot study of 50 sample from your data set can go for your value. There is your data sets. So with these calculation, there is z is your standard table value from the normal distribution. S will be your sample standard deviation, which is a pilot study. So before going to the any problem, they'll be doing with a pilot study of sample 50. So 50 the number, you can go within 50 or 60, you can go within some pilot study number. So then you have to calculate your acceptable error. So here fixing up of your 95 and 5, these numbers are most important. That is that you are accepting the error for up to the 5%. This has to be clarified clearly. Sometimes you may be going with an acceptable error as in 10%, or sometimes you can go with an 1%. So it varies. So the sample size calculation can be done as like this, ZS by E whole square. So there's some sample data have been collected, 0.665 by alpha, that is your acceptable error 0.05. With this you got an approximate number as 682.78. You are making it as an 683. The sample size has been decided as 683. So you can decide like this. So this has been referred with a book here in research methodology. Most of the cases will be going on with this, but some of the cases they may be going with an 10 or 5% as like here. So here these 5% or 1% will be decided with the particular problem or particular company manager. They have to decide with the error. What will be their error cases? Then you need to go with an one more important part is that for any problem you need to define the statement. So one, just you think that if you are writing it as an hypothesis generally, so before going to the types of hypothesis, if you are calling it as an hypothesis, this hypothesis is nothing but a statement again, which may or may not be true. So if I am giving a statement clearly, you can identify that the statement is true or is false. When you are not able to that. So whether you get rain today, So it is an optional question. That is, you may get the right, you may not. So that is that the statement may or may not be true, where you are having an hypothetical part. So in those cases, you are going for the testing procedures. In that, two important things are the null hypothesis and alternative hypothesis. So before going to that, in which type of situations you are arising with the problem? Second, I will come again to this slide just to see here. See the first one here. The company XYZ manufactures the calculators with an average weight of 450 grams. An engineer believes that average weight to be different and decides to calculate the average mass of 50 calculators. You can see the question here. If they've been preparing the manufacturing the calculators, so they've been giving the average weight as 450 grams. Average weight as 450 grams here, which means that it should be in an 450. Each and every calculator should be in an 450 grams. Or if I go for an sample, the weight should be the number. But in all the cases, it may not be the same. So for verification, you need to go for a testing procedures, that is testing of hypothesis. Similarly, in the second example, you can see that the teachers in a school believes that at least 80% of students will complete high school. So that is that they are having an hypothetical statement. At least 80% will complete. So to verify that, you can go with the testing procedures. Similarly, in the last one, you can see that the percentage of residents who own a vehicle in town XYZ is no more than 75%. So whether to verify these type of statements, we are going for a testing of hypothesis. So apart from that, I can also give some general examples. Normally, you may be having a doubt regarding a particular cases. If you are entering into a particular class or particular into the college, so regarding the students' knowledge levels, you may not be known clearly. You have to identify by testing them. So by keeping exams, or by keeping some asking some questions. With that, you can you can have a clear idea about them. So whether they are able to answer the questions, at the same time whether they are able to present their answers. So the situations wherever you are arised with may or may not be situations, then you can go for identifications. I can go for this an alternative hypothesis. So for any type of problem, you need to frame the null hypothesis. There is a definite statement. So null hypothesis should be speaks about the population parameter. At the same time, which will be a no difference statement. Generally, it will be called as a. So here you can see that H naught mu equal to mu naught. It means that there is a population mean and the sample mean will be compared here. Similarly, in the alternative hypothesis here, which is a complementary part to the null hypothesis. So there is a reversed one. Here you are saying that in the null hypothesis it is equal, whereas in the alternative cases you are saying it as an mu will be not equal to or greater than or less than. You are giving within three different cases. If it is you are saying it is an not equal, then you are saying it is a two-tailed test. So I can go with again in the next for the slides. Right tail or left tail, that is mu greater than mu naught, mu less than mu naught. We are calling it as an one-tailed test. You can see here null and alternative hypothesis. H naught you are defining as an application of biofertilizer X do not increase the plant growth. So that is the H naught here. Whereas the H1 will be the alternate part, that application of biofertilizer X increase the plant growth. So here you are saying that before taking the biofertilizer, after the biofertilizer, there is no improvement in the growth. You are saying in the H0, there is an equal statement. Whereas here it is an not equal statement, or sometimes it may be less than or greater than cases. I can give you a simple example for this one, null and alternative hypothesis cases. So let us, if you are entering into a class, as earlier I mentioned the example, you will be having assumption that all the first of all the first time you are entering into the class, you may be having assumption that all the students are having the equally knowledge. You may be having assumption. That's what you are calling it as a null hypothesis. Then further, after getting the examinations or further after getting the updates from the students, you may have some decisions. So if you are deciding that this maximum number of students, that is the students are not equally knowledge, that is your two-tailed test simply. Or if you are making in particular that but half of the class is knowledge, the half of the class is not, that is greater than, less than, if you're having any comparison, you're making it as a right and left tail. Similarly, any type of committees will be visiting. Generally, it may be an NAC or it may be an NBA to a particular institutions. So the committee visit they cannot come with an assumption that the particular college is not following any rules. So first they will be having an assumption that there is a null hypothesis H0, that so the particular institution is following the rules regularly. That is, you can call them as there is no difference between the rules stated by the government and followed by the college. Both are same. You are calling it as a no difference statement. So then alternative hypothesis, you can specify that they are not following. If you are simply giving a statement that the particular institute is not following the government rules, you are calling it as a two-tailed. If you are giving it as a percentage particularly, so 50% they have been following, 50% they are not following. If you are giving a number clearly, then you are going with a right or left in generalization. There is a major part here, null and alternative hypothesis. For any cases for defining, you have to be clear with your null and alternative hypothesis problem here. Next, this is your two-tailed and one-tailed test picture here. So here total data sets will be dependent on normal distribution. That is, your data is distributed normally. As earlier I've been shown in the last day, that is your skewness. So if your data, if you've been plotting your data as a graph, if it looks like bell-shaped curve, then you can say that it is a normally distributed data. So why you need to use the word normal every time? Generally, I'm calling it as he is a normal person. The situation is normal. You are calling it as an normal is a common word which you are using in our daily life. So it means that the activities has to be happen without any biasness. Let us, if I am going for collecting a sample, in those cases, in collecting the sample, I need to have the justification of all the categories. I cannot go with a particular category. So let us, if I am going for a survey of collecting whether the particular city is well reached or rich or middle, that is as per the income, how the city levels are there. So if I go for the collection of data, I need to make sure that my data set covers the total city. So from the starting point of the city to the ending point, which includes all the parts. It is let the city may be divided as an 4 to 5 zones. In all the zones, I need to collect the data. Let us suppose if I am collecting the data from any particular one zone, that is I'm calling it as the biasedness, where I cannot get the normality. So the normally is that the particular city has to be divided as an equal 5 or 6 number of zones. In all those zones, the data has to be collected. So that's what here the data should be in a normal case. You can see that in a normal distribution here, if you have been going with an both the data, whatever you have been chosen here should comes under this normal curve. So yesterday I have been shown regarding the regression. If you have been plotting a particular graph, that is, it may be an exponential or polynomial, which should which should be made coverable with the all the data points. Similarly here, if it is comes under the total region here, you are calling it as an the two-sided cases here. So whereas here it will be an rejection part, that is your alpha by 2 here. Similarly, these will be your acceptance region. So I'll go for an H0 and H1. You need to accept your H0 or reject your H0. In those cases, if you are accepting, then it will be in the middle of the part here. Whereas if you are going for rejection cases, it will be in the at the end of the two tails, where you are calling it as an critical region. So let us, if I am calling it as an 10% is the rejection region, that is 10% is the acceptable error. So then alpha by 2 means it means that 5% at the right side, 5% at the left side. That is both the ends here. Whereas coming out to the one-sided test here, your rejection region will be at only one end, either at the left, either at the right, as like here. So if you are going towards only the right, then you can call them as an right side will be your critical region. You can call it as an one-sided, or you can call it as an right tail test. If you are going for an left here, you can call it as an left tail test. That is the two different cases in the one-sided. Generally, you can go with an error, as sometimes you may be accepting the H0, sometimes you may be rejecting the H0. So that part you can go with an discussion here. But here you may have two different errors. There is two different errors in the case here. So let us see this table here. You can understand clearly. If your H0 is true, you are accepting the H0. So then it is your correct decision. Similarly, if your H0 is false and you are rejecting your H0, then it is your correct decision. If you are going for the reversed part, then you may be facing with two different cases, that is with type 1 error and type 2 error. So this is a type 1 error. Here your h0 is true, you need to accept it, but you are rejecting the h0. It means that you are doing the type 1 error. Similarly, your h0 is false, but you are accepting. It means that you are going for the type 2 error. So why I have been specified the word producers risk and consumers risk here? In a management point of view, you can think that h0 is true. Let us h0, you think about a product. Your product is a quality product. h0 is true. I am saying that the particular product is a quality product, but you are rejecting. A quality product is rejected by a company. It means that the particular company itself will be in a risk. So they themselves are rejecting their quality. Now, second thing you can see here, same again, your h0 false, you think about a product. So the product is a defective one, but you are accepting. Your product is a not good one, but you are accepting it. It means that you are committing the type 2 error. That is the consumer's risk. So because they have been accepting the defective products into them and they are getting into the market, the particular products will be bought by the consumers. So the consumers will be facing the risks. That's what I've been specified as a producer's risk and consumer's risk. You can see with a picture here the type 1 error and type 2 error, how it can be happening. Now, one more term is degrees of freedom will be discussed in the term. So here I am giving what are the terms you are using in the hypothesis. So degrees of freedom here, it is simply a number which is speaks about the how many number of values or how many number of variables are independent or free that you can identify. You can see with an example here. If I ask you to choose any 4 numbers freely, you can go with an any. That is any rough numbers you can choose. But if you are posing any particular condition on that number, on those numbers, the final sum should be equivalent to a number 100, let it be. So then you can choose 3 numbers easily, whereas your 4th number will be dependent on the last 3 because the sum should be 100. So that is a part here. I've been given with an example as in sum is 50. So one of your sample or one of your number will be dependent on the previous one. So that's what you're calling it as an degrees of freedom. Generally, the degrees of freedom calculation will be considered as an n minus 1. Let us, if you're having an n number of samples, in those, one of your sample will be losing the freedom. That's you are calling it as an degrees of freedom here. So coming to final the decision part here, we will be having a test calculated value. That is with it may be a Z test or T test or ANOVA, whatever the test you have been applying. With that, you may be getting a calculated value. That is your test calculated value. If it is less than the table value, then you'll be accepting the null hypothesis. Otherwise, you'll be rejecting the null hypothesis, which is the process we are doing in a manual. So now, if you have been discussing with an software, it may be an Excel or any other statistical software, it must be a p-value, that is your probability value. Here this probability value, as you know that the probability value will be ranging from 0 to 1. If it is ranging from 0 to 1, you need to compare your probability value with your alpha, that is your level of significance. That is what you have been speaking about, 5 or 10 or 1%, what you have been chosen there. With those numbers you need to compare. So here you can see that if your p-value is 0 to 0.01, 0.01 is a mean that 1%. So then you need to reject your null hypothesis at 1% level. It is highly significant. Similarly, if it is ranging between 0.011 to 0.05 up to 5%, then you need to reject your null hypothesis at 5% level of significance. In other cases, you can accept your null hypothesis at 5% level of significance. So here you can see that the level of significance has been classified as a parts as an highly significant, significant, not significant. You can classify it as in 3 parts here. Just we have been come across these set of terms here. So population parameter, that is mean, variance, standard deviation. Similarly, sample, it means that the statistic, that is your sample mean, sample variance, sample standard deviation. Hypothesis, confidence interval, which are the basic terms 95, 90, 99. Level of significance will be 5, 10 and 1. You can go with a test procedure as one tail or a two tail. While doing the test procedure, you may be come across the two case errors, type 1 and type 2 error. Degrees of freedom will speaks more, that is independent of your observations. Then identification of test statistic, that is your or what type of test you are going to do. Then finally you are going with an making the decision. So identification of test statistic, what you are going to discuss in the next further slides. So making decision, just now you saw that comparing your calculated value and table value, you are going for your calculations. Now uh, procedure, generally in your testing of hypothesis, the basic procedure you will be following with these. So what are the tests you are doing? The basic 5 steps will be as like here. So preparing your H0, preparing your H1, then go for your level of significance alpha. So 5, 10, 1, which is the standard value, but you can go with a different number also. Identification of test statistic, whether you can go with the Z test or T test or F or ANOVA. So just I can give a simple words here for ZTF when you can apply. Normally, if your sample size is large, you can go for the Z test. If it is small, you can go for the T test. It is a theoretical process and manually what you are doing there. But coming to the live problems and live examples, in a large samples also, you can go with the T test as it is. So that is defined for an theoretical part here, but for maybe a large and small test, you can apply with the T. So when then why the need of the Z test? You may be having a question there. If you are known with your population standard deviation, then you have to go with the Z test. So I can go with the detail there. Similarly, for F test and ANOVA, if you have been going for an variations where you are calculating the variation between the variables, you can go with an F and ANOVA. You can see in the details here. The final decisions with your p value, that is your probability value, by comparing with your alpha, you can decide. You just earlier I've been shown the table. If you are able to remind your table, it is easy. Or otherwise, I can give a simple clue here. Making decision. If you have your p value here, if it is less than your alpha, so 0.05 is nothing but your alpha value, that is 5% or 10% or 1%. If your p value is less than alpha, reject your H0, otherwise accept your H0. If you remind the term here, you can easily write. But here this highly significant or not significant is a particular case to know that what type of problem you are having, how it has been happened. Okay. Now I can go with an just I will go with the test procedure, how we can apply. Then I can go for the Excel, how we can conclude there. So coming to the student T test, you are having an 3 classifications, that is T 1 sample test, 2 sample, and T paired. So the purpose of the T test here is to identify the difference between the average, that is average of sample 1 and average of sample 2, or average of population 1, average of population 2. If you want to compare, you can use the student T test. That is the comparison between the population or between the sample in respect of mean. Here one more added a word that where the population standard deviation is not known. If your population standard deviation is known, we have to go for the Z test. So, but in live problems, most of the cases your population standard deviation will not be known. So simply we cannot we can go with the T test. The first one T1 sample here. So here T1 sample, the purpose is that you are comparing a population with a sample. There is, you are having only one population and you are comparing the population with the sample. You can see the example here. The average nicotine content in Gutka can be verified by drawing a sample. So average lifetime of electric bulbs can be tested by drawing a sample. Here the nicotine content in the Gutka is your total population. Whereas you are calling it as an the preparation of Gutkas has been considered as a population there. To verify, you are collecting some sample and you are identifying how much nicotine content has been involved. Similarly, the production of electric bulbs or the lifetime of the electric bulbs will be the total population there. In that, to verify, you are collecting some samples of electric bulbs and you are testing its lifetime and you are comparing your total population and your sample. Now you can see that in each and every company they'll be giving a number generally. That is, electric bulb company, they'll be specifying that this much number of hours our company will have a lifetime. That is, they may be given with an 800 hours, or they you can see with an example mobile, they'll be giving the battery time will be that 7 hours long lasting battery. They'll be saying that, that is, without charging you can use your mobile up to 7 hours or up to 8 hours. They'll be giving within some numbers. So to verify whether it is right or wrong, you need to collect some samples from the company. So then you have to identify whether it is actually having the same 7 or 8 hours. So with that cases, we can have a hypothesis cases here. You can see the procedure here, how can do in the T1 sample. So here you are comparing the sample and the population. So H0 will be a no difference statement. You are writing it as an there is no significant difference between sample mean and population mean. And in a H1 you are going with the alternate part that there will be a significant difference. Here I am using the word that significant every time. The significant means that the difference will be an most important. Sometimes you may be having an minute differences, it may not be considered there. So if you are having an important differences, you may be considered. That's you can go with an H1 that there is a significant difference between sample and population mean, where the level of significance can be chosen here. You can see that t test one sample here. There is t as x bar minus mu by s by root n. There is a formula case here. Your x bar will be the sample mean, mu will be the population mean, s will be the sample standard deviation, n will be the sample size. There is a terms here. Precision, you can see that if your p-value is less than 0.05, then there is a significant change. Otherwise, there is no significance. Where you can give it as a number here with n minus 1 degrees of freedom. So this is for the one sample case here. Similarly, you can also go with for the two samples. I can give example here. That is, if you are comparing the two samples, or you can make that two populations has been considered and you are comparing those two, then you can identify these student t-test. And if you are going with the mean based data, you can see that average IQs of couples, husband and wives, average speed or time taken of a horse A and a horse B in a particular track. So here you are having an two categories. So horse A, horse B, two set of populations. The one particular category of horses are calling it as an horse A. One particular category of horses are calling it as a horse B. You are having in two different populations. In those cases, you are comparing these two populations whether there is any difference. In comparing these two cases, you are going with an average, that is mean. You are calculating the average speed of horse A. Similarly, you are calculating the average speed of horse B. In the one more example here, average IQs of the couples. So average IQ of husbands, how it is there. Similarly, average IQs of wives, how it is there. Then you are comparing those numbers. So for these comparison cases, you are having the same procedural format here. So your H1 will be there is no significant difference between the sample mean, or I can also make that the samples has been drawn from the same population. So both the populations are same. You can also use a word like that. H1 will be the alternate here, the two sample. Here in the Excel part, T1 sample has to be done manually, whereas T2 samples and paid can be done within menu directly. You can go with a decision clearly as it is. I hope you can understand the difference between student t-test in one sample and two samples. In one sample cases here, you are having only one population and one sample. Electric bulbs, that is the lifetime of electric bulbs, is a single population. You are collecting a sample from the electric bulbs and you are comparing both sample and the population. Whereas in two samples cases, you are having in two different populations here. That is horse A, horse B. So one category of horses you are calling it as an one population A, another one as a B, and then you are comparing both of them. That is, here you are arising with the two samples. Even in your t-test for one sample, in your t-test for two samples, you are using the parameter is mean, the average lifetime of bulb, average speed of the horse. You are using the mean. Hence, you are going for the students t-test. So one more thing here, students t-test for paid samples. After this, you can go for the Excel to see how we can work with these three procedures. Students t-test for paid samples here. Generally, in our data sets, you may have some paid data where I can call it as an x1 y1, x2, y2, x3, y3 as a mathematical. So where you can see such a pair of data. Let us, if you go for an hospital, especially medical example, you may be having a discussion about that. What about the patient's improvement before treatment, after treatment? They'll be having a question. So there will be a diabetic test will be taken as an before fasting and after fasting. So before fasting, how much sugar levels is been there, then after fasting, how much sugar levels is there. With that, they will come out to the conclusion. They will be giving with them treatment. Similarly, if you go for any coaching centers, they'll be giving advertisements like that. The students who are having scores before coaching and then after coaching, where you can have some pair of observations. So the sample will be the same. That is, the student or the sample will be the same, but you are having observations as an pair, where you are going with an two set of cases, x1 y1, x2 y2, like those cases. So when you are having these type of paid observations, then you can go for the students t-test particularly. So I've been given with an medical example. At the same time, I've been given with an medical example. At the same time, in the management point of view, the decisions taken by the management to the company, sometimes they may be going with a new training methodologies for the employees. So how the old training and the new training is differentiated with the before the training, how the employee has been reacted for the production level. Similarly, after the training, how he is reacting for the production level. What is the time taking by the person? If you're having the comparisons, then you can go with the student T paid test. You can have the same procedure here. In the H0, you are specifying the word that earlier you are going with the one sample and two sample, you are going with the mean. So what is the difference between two means, two samples or one sample? Now here you are going with the t-test paid samples. You are making a statement that there is no significant difference between before and after. So that is before training and after training, or before treatment and after treatment. Similarly, H1 your class making it as an there is a significant difference. Then you're going for the level of significance t-test paid samples. Here you can see that xi minus yi will speaks about the difference between the values. So before fasting, what is the sugar level? After fasting, what is the sugar level? That's what you're taking here. Capital S will be your sample standard deviation. N will be your sample size. So you can make your decisions accordingly what you are getting with your p-value. Now you can move with the Excel here. You can go with those three testing procedures here. So coming to the T1 sample, you are not having any direct menu here. You need to do manually. So just you remind your formula here, just which have been shown. So T1 sample, x bar minus mu. This is the formula. Just you remind this formula. With this you can calculate here. X bar minus mu by S by root n, capital S. That is, x bar is your sample mean, mu is your population mean, then S, capital S is your sample standard deviation, n is your sample size. With this formula I can calculate in Excel. So here I've been given a problem here. The blood pressure of 15 patients under treatment for hypertension is given below. Test whether any evidence to show that the sample represents a population of patients having normally distributed blood pressure with the mean 150. So here you can see that 15 patients has been chosen. It means that you are going for your, can we get zoom here? So here you can see that 15 patients has been selected. It means that it is a sample size. So then they've been given with an word as an patients having normally distributed blood pressure with mean 150. So that is, they have been given that commonly the blood pressures of the particular of the patients will be in generally 150. That is a common number. As I've been said that the population mean will be the gold standard value, as earlier mentioned, that a fever temperature or maybe an blood pressure levels, diabetic levels, those numbers will be classified as a population mean directly. So here I'm taking the values directly here. What is n is your sample size, which is 15. Then population mean is given as an 150. So then I need to go for the sample mean. For sample mean, they have been given the data. So 15 patients data has been given directly. So just you can get the average value here. For calculating the average, you can use two techniques here. So first I will go with the auto sum. there is nothing but your automatic sum here. You can see the menu here, auto sum. Just if you click on here, you can get your sum. So it takes all the values. If you keep the cursor active cell and click on the auto sum, if you are having the numbers at the left side or if you are having the numbers at the top, it automatically takes the sum of those. So here I am having the numbers in the top, hence it is taking the sum here. If you click on here, it gives the total. So I'm specifying the total, that is a 2118. That's I'm writing here as it is. Next, to calculate the mean, as you know that the sum of the values divided by the number, total number. Hence, for calculating here, you can use the formula that by typing equal to, you are going to write some formula or you are going to define some calculation. So what is our mean formula? Generally, summing up of all the values divided by total number of observations. So what is the sum here? No need to type your 2118, just you can select the number. You select this number. As earlier mentioned that each and every cell will have an address. It is in the ith column, third row. That it has been taken as an I3. Now divided by, what about the total here? 15. That is the 15 as it is, which is my mean. So to calculate the one more thing here, to calculate the mean, no need to go for the formula. Just you can use directly a technique here. Type equal to, then take it as an average. Type here as average, AB. You can, if you type first 3 letters, automatically the menu will be displayed here, average. Just double click on here. You give the data here. You are having the data of blood pressure. Just you select the data. Whatever the data you are having, just select it. 15 observations. You just close the brackets here. Average of B4 to B18. It means that Bth column, 4th row, up to Bth column, 18th row. Just you click on enter, you get the value. No need to use your formula. It is a formula that is a sum of all the values divided by total number of observations. You can get directly. That is 141.2. Now for standard deviation, same thing here. Just type equal to, then write it as an STDEV. If you type those letters, that is standard deviation, STDEV. Select the observations same as this. All your 15 observations. So from first one to last one. So here you have to make a note that yesterday while selecting the data, every time you are doing the selection including the heading. Now you are not using the heading here. You have to make the difference clearly. Yesterday it is an data analysis menu, hence you have been went with the headings. Here you are calculating with the numbers. So here you cannot go with your text. So it should be the numbers. So standard deviation, we are getting the number as a 23.2723. Then coming out to the test statistic part, as I have been shown the formula here, you can see once again that is T is equal to x bar minus mu by S by root n. This is the formula. Just I can calculate here. You can use the same calculation procedure, type equal to, then open up a bracket here, sample mean minus population mean. What is your sample mean? 141.2. So select your number 141.2 minus population mean 150, then close the brackets, divided by S by root n. S means it is a sample standard deviation, that is 23.2723. Again divided by root n. So for square root, you can use a function called SQRT, which is a square root. Square root of n. What is your n value? 15. Close the brackets. Again you can close the brackets. How many number of brackets has been open? You have to verify clearly. So here I've been open for 2 number of times, hence I've been closed for 2. So if you press enter, you'll be getting the T value. So the T test statistic value, we got it as an minus 1.4645. Already I've been said about that the comparison between test statistic and the table value. This table value can be obtained from the predefined table t-test. In the internet itself, you can obtain that t-test table values. You can obtain directly. So with that, one more thing here, number of degrees of freedom. Earlier I mentioned that if you're having an n number of observations, then one of your observation will be losing freedom. That is n minus 1. I'm having 15 observations. It means that 14 is my degrees of freedom. One of the observation will be losing the freedom. So hence I'm calling it as a 14. Now, Generally, the test statistic value will be negative or positive. You'll be going with a modulus generally. The particular formulas, you'll be considering generally the formula is x bar minus mu by s by root n. But in calculation parts, you'll be using the modulus here to take a positive values. Here you can write it as a, if you take it as a positive value here, you can compare, or I can use one more function, then you can understand clearly. There is a modulus can be applied here as an ABS, is absolute value. The type is an ABS, which you are taking it as an modulus. Plus enter, it automatically takes as an earlier it is a negative, now it is showing it as a positive value. Now you can compare your T calculated value with your T table value. Here your T calculated value is less than your table value, then you will accept your H0, which I have been shown earlier in your decision making. You can see here. Making a decision. If your calculated value is less than the table value, then you can accept your H0. In our Excel case, it has been happened as like this. So you can see that T calculated value is less than the table value, hence you will be going for accepting the H0. First, initially you need to define your H0. I will skip here. If you're going for defining the H0 here, so here the discussion is between the sample and the population. So I can write the H0 as an, there is no significant difference between the sample and the population mean of the blood pressures of 15 patients. So in H0, I'm taking it as a neutral statement, or I can call it as an equal statement, no difference statement. That is, there is no significant difference between sample mean and population mean of the blood pressures of 15 patients. That is my H0. Whereas in my H1, I can call it as an, there is a significant difference between them. That is my H0 and H1. Finally, I am accepting the H0 here. So the alpha levels here, the alpha has been not mentioned. Default I am going with the 5%. For the 5%, the value is 2.97684. That's what I will choose here. But the t-test one sample will be in rare situations to do. In some of the cases they will be going, but most of the real-time problems will be going with a more number of samples. Now you can go for the T2 sample here. Just you can read the problem here to. So here I can use the menu directly. To examine the hypothesis that the husbands are more intelligent than the wives, an investigator took a sample of 10 couples and administered them a test which measures the IQ, and results are as follows. Test the hypothesis with a reasonable test at the level of significance at 0.05. Alpha is given as 0.05 here. Here the problem is not specifying clearly with to do particularly t-test for 2 samples or z-test. Yes, they have been given directly. So here they have been comparing with the average. That is, they have been comparing with the IQ levels of husband and wives as given in the previous example here. So 10 couples has been chosen. Their respective IQs, respective husband and wife's IQs has been given here. So we can calculate the t-test for 2 sample here, since the sample size is less than 30. At the same time, to compare the husband and wife IQs, you can go with an average general. Now I will go for the menu data here, as earlier mentioned, data analysis. Here you can see that t-test for 2 samples. So t-test for here you'll be having 2 set of cases. That is t-test for assuming equal variances, unequal variances. Generally, you'll be going with that. Both the samples are having equal variances, but I will show that for unequal also how it will be working. Select the t-test 2 samples assuming equal variances. Click on OK. Then it will be asking about that variable 1 range, variable 2 range here. So for variable 1 range here, first we have to select the data. That is the IQ of husband. Here I am selecting along with the title. Okay. Now variable 2 range. Here you are using with the data analysis. So in the second one, similarly, you can go with the second variable and select the data, that is IQs of wife, including the heading. Hypothesized mean difference. Already mentioned that the hypothesized mean difference will be neutral. That is that equal. You will be saying that it means that it will be 0. So next thing is that you need to tick upon the labels here. If you are selecting the labels, it means that you have been selected the heading. The first row is heading. Then it is alpha. You can change your alpha 0.05 or 0.01 or 0.10. What are the numbers you need? But here in our problem it is 0.05. You can leave as it is. Then select the output range. So you need to give some empty cell here. Just I'm selecting some empty cell. Click on OK. Now we can see the t-test for two sample assuming equal variances. So here it is directly calculating. So first mean of first variable, second variable, variance of first variable, second variable, observations count 10. So here it is pooled variance. I've been saying that it is a t-test assuming equal variances. When you are saying it is an equal variances, you are calculating the combined variance of both the samples. Hence you are calling it as a pooled variance. Then hypothesized mean difference is 0. DF, it means that degrees of freedom, which is 18. So degrees of freedom has been calculated as an generally n minus 1, as already I mentioned here. The same thing here. What is the first sample size here? We're having 10. 10 number of samples has been collected. 10 minus 1, it means that 9. Again, you're having one more sample, that is a 10 here, that is 10 minus 1, 9. So then 9 plus 9, it means that 18. So degrees of freedom will be common thing, that n minus 1. Okay, here you're having two set of samples. For the first sample, n1 minus 1. For the second sample, n2 minus 1. So it is your totally n1 plus n2 minus 2. Mixed you can call it as that. Hence it is an 18. Next, t stat, which is your t calculated value. Then p value for one tail. Then t critical value, one tail. Similarly, p two tail value, t critical value for two tail. So here you are having an all the classification. The problem may be an one tail or two tail. You can calculate. So with these p value, we can go for the decision. So whether you are going to accept or whether you are going to reject, you can make with your decisions. So you can see with p two tail here, that is 0.24. So 0.24 means it is your value as an 24%. So you can compare with the 5. Here alpha value is 0.05. Here it is a larger value. It means that you need to accept your H0. That is your t-test for two sample assuming equal variance. I can also do for unequal variances. You can understand clearly. So data analysis. So t-test two sample assuming unequal variances. You click on OK. I'm going for unequal variances here. The same part you have to do here. You have to select the variable 1, first variable. Then you have to go for the second variable. Hypothesized mean difference will be 0. So here it is a data analysis. While selecting the data, you can go with the headings. Now select the labels here where you have been selected the heading. Alpha 0.05. Go for your output range by giving some empty cell. I've been selected some empty cell here. Click on OK. You can get the same data. So here you can see that mean has been given, variance, the same data sets has been given here, but only difference is that you are not going for the pooled variance. Here you are having additional concept as an pooled variance. Here you are not going with the pooled variance. Your t stat value will be somewhat similar here, 1.19. Your t two tail values you can see here 0.2424. More or less it will be similar. But in data sets, if it is in larger cases, there may be changes may be happen here. This is about the T2 sample. So here in the question, here you can go for the H0 and H1 as. If you are going for the H0 here, they have been comparing the couples, that is a husband and wife's IQs. I can take a no difference statement as there is no significant difference between the IQ levels of husband and wives. That you can call it as an between them. Similarly, in the H1, I can write as an there is a significant difference. But here they have been posing a statement that the husbands are more intelligent than the wives. So then in that H1 you can use this more. It means that greater than. It means that one tail test can be applicable here. Next we can go for a T paid test here. So the see the data sets here. The blood cholesterol of 10 patients has been observed before and after giving a special diet that could reduce the cholesterol level. The values are given below. So carry out a suitable test to if the average cholesterol level has decreased after the diet. So a diet has been given to the patients. Already I mentioned that if you're going for an T paid automatically. So what about it is before the diet, after the diet? We're going with the two different cases. So before diet, they have been given with the data sets here. 10 data sets has been given. Similarly for the after. That is the 10 patients is common. It has been not changed. For the same 10 patients, you are calculating the before the diet how their cholesterol level, after the diet how the cholesterol level. Here the sample is only one sample. You are not going with the two samples. Whereas in the previous case, husband and wives, the husbands are the sample 1, wives are the sample 2. But in the paid test here, you are having only one sample. That is, you are going with only 10. You are having only 10 patients. So those 10 patients has been selected. For them, you are calculating before and after. So you are having only one sample. So T paid test, the data will be paid, but the sample is only one. Now you can go for a T paid here by clicking on data, data analysis. Then you can see that T test paid to sample for means. You can select this one and you can click on OK. So same again, you have to select your variable 1 range, that is your first one before the diet, including the heading. Next variable 2 range after the diet, including the heading. Next, sorry, it has been variable 1, you have to go with the first one before the diet. Then variable 2 you select there and you go for after the diet. Hypothesized mean difference is 0. So every time why you are taking as a mean difference as 0 here, every time you're going with an H naught as a neutral statement. There is no significant difference between sample mean and population mean. Or here there is no significant difference in the patient before and after the diet. So that's what you're specifying as a 0. You can click on the labels here. So that is including the heading. In the output range, you select your empty cell to get your data. Select any empty cell, click on OK. You can see the data set here. So before the diet and after the diet, how it is there. So they've been calculated the mean here, variance, observations totally 9. Sorry, in the question it has been mentioned as 10 here, 9 observations. Pearson correlation. Here they have been calculated the correlation. So already mentioned that before and after for the same patients you are calculating the cholesterol levels before the diet and after the diet. So there should be some relation between them. So before the diet and after that there may be an improvement, there may be no change, there may be no improvement. You can have some 3 different categories. So there is some relation. So the change may be happened. Hence you are calculating the correlation here. 0.374. It means that positive correlation. 37.4% correlation is there. That is one of the variable is increasing, the other will be increasing, or one is decreasing, the other will be decreasing. You can see that Pearson correlation here. Then degrees of freedom. Totally you are having 9 samples, so 9 minus 1, it is 8. So in the question here it is mentioned as 10 here, it is only 9. Yeah. So 9 minus 1 means degrees of freedom is 8. You can see the T calculated value, T table value. Now coming to the H naught part here, we are discussing about the patients here, 9 patients. So I can write the H naught, no difference statement as there is no significant difference between the patients before and after the diet. Whereas H1, I can say that there is a difference. So now you can see the values here. Alpha is 0.05. So now if you go for the two-tail case here, 0.02. So which is less than 0.05. Then you need to reject your H naught. Whereas in the one-tail case also 0.01, you will be rejecting the H naught. 0.01 is less than 0.05. You will be rejecting the H naught. This is about the part for your T paid test here. So you can go on here, go for the PPT one. So for t-test have been completed here up to t-paid. So there is a z-test part here. In Excel, I'm not going for the z-test here, just I'm giving a brief thing. T-test will be more than enough to do the analysis part here. Z-test will be applicable if and only if your population standard deviations, if you have been known with that one. In those cases only you can go for your z-test cases. Let us go for the f-test here. F-test is a main purpose to calculate, to study the difference between the variances. Let us, if you are having the difference between the variances between two variables, then you can go for the F-test here. You can see some examples. Time taken by workers in performing a job by method 1 and method 2. So what is the variation in the time? So by doing in the method 1, how much time they have been taking, by method 2, how much time they have been taking. You are comparing the variation between the time. Similarly, heat producing capacity of specimens of coal from two mines, how much heat has been produced in mine 1, mine 2. You can see the variation. If you are going for the variations, you can go with the F test here. Earlier in your t test, you are going with your average every time. What is the average difference, your average difference between the two samples, or average difference between the populations. Now here you are using the word as a variance. So you can see as like that, when you compare, when you are having the time, or when you are comparing with the heat produced here, you can go with these two cases. Next, after completing this F-test and ANOVA, directly will go for Excel, then you can understand easily. So F-test and ANOVA is somewhat linked here, you can understand. So the analysis of variance, ANOVA is a major part here to discussion of more than two variables. In your t-test, in your F-test, you are discussing only for two variables. What about if you are having more than two? More than two. So if you are having more than two variables, then you need to go for the analysis of variance, ANOVA cases here. Here, these analysis of variance will be used to calculate the differences between the more than two variables in respect of mean, in respect of variance. It will be helpful. But the final analysis of variance, the technique you'll be using is that F-test here. F-test will be used generally. In those analysis of variance, you're going with three types here. In the Excel, you can go up to two, one way and two way. That I can explain here. So you can go directly here. Just I can come out to the last chi-square. So F-test you can see here. That is in the F-test case. I can make zoom. The company is comparing the methods of producing pipes, and the company wants to choose the method with the least virility. A sample of length of pipes using both methods are given below. So for preparing the pipes here, they have been specified within two methods, that is method 1 and method 2. What about the pipes production levels? That is 4.7, 3.7, they have been given with the numbers. So to compare the variation between the method 1 and 2, I'm not going for the average here, t-test, I'm going for the comparison with the differences, method 1 and method 2. So for this part, you can go with the F-test here. You can go for, first here you can define your H0 first of all. Here you're having the discussion about producing, there is least virility. Virility in the sense, what about the breakable strength will be, has been discussed here. So I can say that in the H0 there is no significant difference between the pipes by producing from method 1 and method 2. In H1 I can say that there is a difference. So where you can define your H0 and H1. Now you can see the data analysis here. We can go for your analysis part here. You can see that F-test. So you can see F-test 2 sample for variances. F-test cannot be done for one sample, because for variance you need to have two samples. If you select F-test here, click on OK. So give your first variable. The process will be same here. Select your first variable. Then go for variable 2, second one. Select the second variable. The first variable has been given, second variable. Select the labels. You are selecting the heading. Make the difference that if you are defining a formula by typing equal to, you need to go for only numbers. But in the data analysis menu, what are the thing you are doing? Select with the heading. So give some suitable heading and select those. It will be easy to display your answers. So I'm selecting the output range here. Alpha default I have been given with 0.05. Give some empty cell. Click on OK. Now you can get your if test. So you can see same mean, variance, number of observations has been selected. Degrees of freedom, you can see that first you are having 9 samples, so 9 observations, so 9 minus 1, 8. Next you are having 15 samples, 15 minus 1, 14. Then you can go for the F test, F calculated value 2.09. Then the probability value, P value has been given 0.1. So then you can have the comparison with 0.05. So 0.1 is greater than 0.05, hence you can accept your H0. You can go for the decisions as like this here. That is in your F test part here. Then you can go for one-way ANOVA. So here in the one-way ANOVA, I have been given with a question that a marketing research firm tests the effectiveness of 3 new flavors for a leading beverage using a sample of 30 people divided randomly into 3 groups, 10 each. So group 1 tests for flavor 1, group 2 for flavor 2, group 3 for flavor 3. Each person is given a questionnaire which determines how enjoyable each flavor was. Determine whether there was a significant difference between these 3 flavors. So with the flavor 1, 2, 3, what is the difference here? You're having more than 2 variables. You cannot go for t-test, you cannot go for your F test. You can use the same data analysis here. Then ANOVA single factor. If you click on ANOVA single factor, click on OK. So here the input range has to be given combinedly. No need to give as a variable 1, 2, 3. You can select your total data at a stretch. So 3 variables. So it is grouped by columns defaultly. So generally our data will be in a columns only. Select labels in first row. Alpha 0.05. Output options, output range. You can give the empty cell and click on OK. Now it will be displayed as like. First they have been given the summary. First in the flavor 1, what is the count, sum and the average variance, basic statistics has been given. Then the ANOVA table has been defined here. Now you can see finally this is your F test calculated value 2.51 and you are having your P value 0.09. If you compare with your alpha 0.05, 0.09 is greater than 0.05. It means that you are going to accept your H0 here because it is a larger P value compared to your alpha. Or you can also go with your table value. Here it is the F calculated value, F table value. You can also compare with these two. If your F calculated, you can see that it is F calculated value is less than your table value. Hence you are accepting. In any way you can get the same terminology. The same fashion you can go for two-way also. So two-way just have been done directly here. I'll show again. So go for data analysis. So ANOVA 2-factor with and without replications will be there. Go for without replication. So with replication, you need to specify the factors, how many number of factors has been divided. But most of the cases will be going with without replication cases here. Just to select your data as it is. The total data. No need to go for variable wise here. Select the labels. Output option here. Click on your empty cell. Click on OK. You can get your terms here. First, the summary has been given. What about the sum, average, variance has been given here. Then in the ANOVA here, ANOVA 2-factor in the sense it has been going with both the ends, rows and columns. In ANOVA 1B ANOVA, they are going with only either by column or either by row, only in terms of flavor. Whereas here in the two-way, you can see that it has been going within two ends. You are going with the row based. We are also going with the column based. That is yield A, yield B, yield C, yield D. That is for in respect of yields, in respect of fertilizers, nitrogen, potassium, phosphates. You are going within both the cases. That is meaning that here rows and columns. So rows means that fertilizers point of view. Columns means that yield point of view. A, B, C, D. You are going within. You can see your F test calculated value in respect of row, in respect of column, 2.4, 3.6. Critical value 5.14, 4.75. In both the ends, the value is less than. There is F calculated value is less than F table value. You will be accepting H0. Sometimes you may be having a difference in terms of row. There may be a significant. in columns there may be having an not significant. You may be having an two classifications. So this is for the ANOVA two-way part here. Let's go with that chi-square test part here. Apart from your previous, I hope you can understand with the ANOVA two-way cases. Three-way will be a different model here. In Excel, you will not be able to perform your three-way. Three-way have to go with an three-way will be the manual part here. So coming to this chi-square test here, which is a non-parametric test. That is, you are having a comparison between your observed frequencies and expected frequencies. You can see the example that if a fake coin tossed for 100 times, the probability says that 50 heads will be given, similarly 50 tails. That is, the theory will be speaking there, but in practical you may not be getting the same. That is, theory which you are saying it as an theoretical data, and you are comparing with the observed data. With those, you are going for the chi-square test. You are calculating the difference between theory and observation, which is called as your chi-square test. So if you are going for an any social surveys generally, you may be having an data, so which is an observed data. With that theory, you can compare. The theory part is that distributions that that will be having another type of versions here. Just I can brief out the example here. Chi-square form will be defined as a difference between the observed and expected OI minus EI whole square by EA. Here the degrees of freedom will be M minus 1 and N minus 1. So which is for your attributes cases here. Once again, I'll go with that. Goodness of fit can be calculated with the average or a criteria or distribution. Three different cases. In Excel, you need to calculate the expected frequencies. Then you can go for the Excel calculation. Whereas in the other cases, just if you give the data, you can get the chi-square distributions here. And goodness of it here. Similarly, in the independence of attributes case here, which is defined for if you're having any attributes as like drinking habit or smoking, blindness. So these are all the habits you have been listing here. For these habits, you can go with the sum generally. So how many of the persons are having the habit of drinking, habit of smoking? You can go like the calculation. You cannot measure the habit. You can calculate the presence and absence of the habit. That is the two cases you can do here. I can chi-square cases here. In the goodness of it, you can calculate with the three different cases here. Average, criteria, or distribution. Just I discuss about the average here, how you can do. In the Excel part, I can do here directly. Chi-square test here. Yeah. The number of, just you can see the question here. Just I will zoom again. You can see the data here. So the number of automobile accidents per week in a certain community has been given, that is 12, 8, 20 like this. Or these frequencies in agreement with the belief that accident conditions were the same during this 10-week period. Generally, you can see the sum here. They have been given the data set here. If I go for the auto sum, I click on auto sum here. You are getting it as a total as 100 accidents total. That is observed frequency here. Coming to the expected case here, for 10 weeks the accidents has been happened. You are counting as like this here. For each week, on an average, you'll be having a defaultly 10 weeks. That is the expected frequency. The expected frequency can be calculated with the average simply, or with the criteria, or with a distribution. If you are going with an fitting of distribution, so that is another new version here. I cannot go with that totally. That is binomial or Poisson. The new versions will be changed again. That is based upon the probability. So I can go with the average simply here. So here totally the observed frequency is 100. It means that in 10 weeks 100 accidents has been happened. Then automatically we can expect that in each week 10 accidents has been happened, because you're having in totally 10 weeks. So total number of accidents is 100 divided by 10 weeks, that is a 10. You can get a number as a 10 directly. Just I can drag the values for all those. So as per theory, that is expectation, you are saying that each and every week 10 accidents has been happened on the average. But in observation, there is 12 accidents happen, 8, 20, 2, you are having numbers. Now the difference between those is nothing but your chi-square. So to calculate this, you can use a function called chi-test, equal to, you can use chi, chi-test. If you use a function, double click on this. First you have to give the actual range. Here I am using equal to, I will not select the heading, just I have to go for the data. So I'm selecting the numbers here, then press comma. You can see what are the arguments to be given is displayed here. Chi-test, actual range, comma, expected range. So actual range I've been selected here, that is my observed. Now expected range I'm going to select. I've been selected here. Press enter, you can get your chi-square value. This is your chi-square test value. Then you can go for your table value, then compare whether it is whether you are going to accept your H0 or whether you are going to reject your H0. You can make your decisions. Similarly, in these chi-square test, we will close with the last method, that is independence of attributes. So in the goodness of it, that whether you are given data, that is what are the data set you have been given, that is exactly right or not, we are comparing with the average. The other two I'm not discussing, just I'm making the average. The one more different concept is that independence of attributes, as earlier mentioned there, the person is having the particular habit, that is the presence of the habit. Especially these problem will be helpful for the social sciences people. They'll be going with an surveys or questionnaires in a particular villages or in particular different regions. They'll be having questions as like this here. What type of habits are there in having the calculations? For these type, the expected frequency calculation will be only one method. You can see I've been given an example here. Observed frequencies. I've been chosen two attributes here, smoker and drinker. So it means that smoking and drinking are my two attributes. Automatically, you may be having a concept as an it is present or absent. If it is present, you are calling it as a smoker. If it is absent, you are calling it as a non-smoker. Similarly, if the drinking habit is there, you are calling it as a drinker, non-drinker. A, B, C, D are the numbers, that is nothing but the frequency. I can say that A number of persons are having the habit of smoking and drinking. Similarly, B number of persons are having the habit of drinking but not the smoking. Coming to the C number of persons are having this habit of smoking but not drinking. Coming to the D number of persons are not having the habit of smoking and drinking. Each and every number will speaks about the attribute. Similarly, you can see the total here, A plus C, total number of smokers, total number of non-smokers. Here you can see the total number of drinkers, total number of non-drinkers. This is your observed frequencies. To calculate your expected frequency, you are having the common formula as row total into column total by grand total. If I want to calculate the expected frequency for A, for this place I want to calculate the expected frequency, I need to go for the formula that respective row total, that is A plus B, into respective column total, that is A plus C, divided by grand total, that is my capital M, which gives my expected frequency for the value A. Similarly, the expected frequency for B, C, D, you can calculate as well. You can make with a small example, you can understand here. Here I've been given with an example as hair color and eye color as two attributes here. Hair color I've been specified as an fair, brown and black. Similarly, eye color as a blue, gray and brown. You can see that each and every number will speaks about the attribute that 15 persons are having a fair hair color and a blue eye color. Similarly, you can see the number 20, let us say. 20 persons are having a black hair color and a brown eye color. You can classify like this. Just to calculate the totals here, just I can use the auto sum. Then I can go for the expected frequency. We can calculate here the auto sum for the column. So you can drag here. This is the grand total, which is 150. Now to calculate the expected frequencies, I'm using the same formula here. So for the first one, equal to, now I'm doing for the 15. For this number I'm calculating here. It is row total, it is 40, into column total, it is 60, divided by the grand total, which is 150. With this I can select the number. That is 15 is the observed frequency, whereas 16 is the expected frequency. Now similarly I can go for this, just I will calculate the first row, you can understand clearly. For the 5, we have to go for 40. 40 is the total. into, for the 5 the column total is 30 divided by grand total is 150. For the last one here 20, the row total is 40 here into the column total is 60 divided by the grand total which is 150. Yes, you can take the sum. Let's take calculate the first row sum here, which is 40. Automatically it tallies with the total. Your first row total, second row total, column total will be matched. 99% the totals will be matched. At the last, the grand total has to be matched 100%. So you are having your observed frequencies here, you are having your expected frequencies here, then you go for your calculation. Observed, then you place your expected frequencies here. Now I'm having the values as 16, for 15 it is 16, for 5 it is 8, for 20 it is 16. For 15, 5, 20, I will calculate as 16, 8, 16. Just I will place. Similarly, place all your values, then apply your chi-test as earlier here. So you applied here equal to chi-test. Give your observed values, expected values, you can place. You can understand the difference now. That is, the observed frequencies is the data collected by the person. The expected frequencies is the theory which you are doing as on your own. Now you are comparing the expected and observed frequencies, whether there is any difference. So you may be having a question, sir. I have been collected the data. That is, how many of the persons are having this type of color, hair color or eye color. I've been collected the data. Then why I need to check this with expected frequencies? The simple answer is that while collecting the data, you cannot assure that the data is 100% correct. You may say that it may be correct for 80% or 90%. The reasons, it is involved with more number of questions, so that leads to different topic again, that is related to the sampling errors again here. So here just a question is that in the observed frequencies there may be some errors, acceptable errors, what I'm speaking again with 5%, 10%, 1%. With that acceptable errors, whether it is right or wrong, to compare my observed expected, I'm using this test procedure as a chi-square. The main purpose of this chi-square test is to go for the difference between the observed and expected frequencies, whether it is acceptable or not, and it means that there is any significant difference or not. So maybe speaking about that difference is that so the differences is directly calculatable. You can see here, the first one here, you can see that here I'm having the first one as a 12, here it is a 10. The difference is 2 here, 8 here, 10. Again the difference is 2. Let it may be plus or minus. The number is 2. Again here it is the difference is 10. By seeing each and every individual difference, I may not able to conclude. So for the first sample, for the second sample, for the third sample, I cannot go for the conclusion parts here. But making the set of all the values, that is, it may be a 10 observations, it may be a 20 or 100 observations. If I go for conclusion of all the differences, what is the difference for the first one, second one, third one, by making the mixed cases of all those things, I'm revealing the number as chi-square test value. So with this chi-square, I can go for the decision whether I'm going to accept or reject. So here in these chi-square, you can define your H0 as, you can see here, in the chi-square cases, you can go for the testing procedures as your in the first one, goodness of it, or it may be an independence of attributes. You can use a common term as an there is no significant difference between the expected and observed frequencies. So the H0 is your neutral statement, that is no difference statement. You are saying that there is no significant difference between observed and expected frequency, which is a common statement you'll be using. So with related to the problem, you can use just I've been given that blue eye and brown here. You can make that there is no significant difference between the observed and expected frequencies in terms of eye color and hair color. In particular independence of attributes, you can also write one more term as an H0 as an there is no association between the two attributes. Here I'm saying taking it as in drinking and smoking. You can write the H0 as a common part, as in there is no significant difference between the attributes drinking and smoking. But if I go for the H1, I can make an argument that there is a significant difference between the attributes. Likewise, you can identify these and all will be helpful in the testing procedures of psychologists. That is, in a testing of a psychology persons, what are the habits are related. If a person is having a particular habit, automatically the person will have also this habit. There is a relation between the habits can also be assessed with these chi-square tests, which will be a very helpful procedures. It may be a psychological product, maybe social sciences, how the person's behavior are there, you can identify with these. So with this part I can close here. These are all the testing procedures that I gone with t-test, ANOVA, F-test and chi-square. These are major testing procedures which you go with the testing of hypothesis in Excel. If you are going for the SPSS, the next level can be converted. So with these things, I can close my session. Thank you all. Thank you for patient listening.
Thank you so much, sir. Your thought-provoking address set a perfect changes among the gathering. Now, I would like to call upon Mrs. J. Srisha, Assistant Professor, Department of Mathematics, to handle the question and answer session on behalf of participants with the chief guest.
Good evening, sir. Good evening to all. And there is a few more questions asked in the chat box, sir. Shall I ask you now, sir?
Yes, madam.
Shall we mention in an article that we did the statistics using Excel? Will it be accepted? They are asking the question.
Generally in the article, they'll be not asking a question that in which tool you have been using in particularly. So they'll be most interested about the results, what results you have been obtained from your data set. Whether your data set is an original data set or you have been collected as an secondary data set. They'll be interested in the question as like this. The software may be applicable with any Excel or SPSS, no need, but the final content has to be given. What are the requirements regarding the problem? That is an important issue.
Thank you, sir. Then, should we state both hypotheses for our research?
Madam, can I repeat again?
Should we state both hypotheses for our research? Both hypotheses.
Whenever going for your problem, both the hypothesis has to be represented, which is the most thing, because you may not accept every time with a one. Let us say if I'm going with only null hypothesis H0, I'm defined only H0. I'm not going for H1, suppose, but it is not a thing that I'm every time I'm accepting the H0. Sometimes I may be happen to accept my H1. Sometimes it may be the H0. So both has to be specified clearly, H0 and H1.
Okay, sir. So student t-test is for parametric or non-parametric data?
Student t-test is purely for parametric. It is for, whereas the chi-square is a non-parametric test.
Then one more question, sir. If population mean was not mentioned, then how to calculate population mean in one sample t-test?
So population mean has to be given in one sample t-test. The population mean has to be given. That's what I'm mentioning, that population mean is not a calculated value directly. It is a gold standard value which will be linked with some number, as like my given my previous example, the fever, temperature, or maybe a blood pressure. So some gold standard number will be there. That is what you can specify with our population mean.
So does the results differ from SPSS to Excel?
Yeah, no, madam. Whatever the thing you are doing, the results will be common, because the background work or background, the formula will be same. The t-test or F-test, whatever thing you are doing, the formulas will be same.
Okay, sir. So in my last question, sir. In MS Excel, can we have between group comparison instead of general comparison as given in the Excel?
Yeah, you can go for the comparison of a group. You can go. That is in the ANOVA cases you can do. You can go with the comparisons here. But in SPSS it will be somewhat higher, where you can make an frequency tables, where you can go with an high level comparisons can be done here. But Excel will be somewhat restricted with some of the comparisons.
Thank you, sir. All the questions are over, sir. Thank you so much, sir, for the question.
Thank you.
Saying thank you is more than a good manners. It is a good spirituality. I would like to call upon Mr. S. Muruganandam, Assistant Professor, Department of Mathematics, to deliver a vote of thanks.
Good evening, everyone. It's my privilege to deliver the success of vote of thanks for today e-workshop on performing statistical data analysis using MS Excel. As digital learning became an needed one at this pandemic, this workshop brought you all to learn advanced concepts in mathematics using online tools held on 18/8/2020 and 19/8/2020 at 3 p.m. in StreamYard, organized by the Department of Mathematics. On behalf of the department, first of all, I thank our founder chancellor A.C. Shanmugam sir for giving us the opportunity to conduct the workshop during this pandemic. I also thank our honorable president, engineer A.C.S. Arun Kumar sir, who firmly believes in our ability and never fails for granting us to conduct today of the workshop at this pandemic situation. I would like to thank our prominent academician of our institute, Vice Chancellor Dr. S. Geeta Lakshmi ma'am, who is the First Lady Vice Chancellor of our university, also who is very energetic person. Thank you, ma'am. With this, I thank our registrar, Dr. C.B. Parnivelu, Provost Dr. G. Gopalakrishnan, Dr. Malini Pande, Joint Registrar of Humanities and Science for their motivation. Thank you, sir. Thank you, ma'am. I extend my sincere gratitude to Dr. S. Ramalingam, Joint Registrar of Phase 2 Campus, and Dr. V. N. Rajavarman, Deputy Dean of Phase 2 Campus, for their constant support and encouragement through the event. Thank you, sir. At this moment, a special thanks to our Dean, Dr. S. Manivannan, who is our backbone of our campus, for giving a wonderful opportunity to conduct this workshop in a successful manner. Thank you, sir. My sincere thanks to our chief guest, Dr. M.Venkateshwaran, who accepted our invitation and sharing your knowledge to all of us. Thank you, sir. I thank our HOD, Dr. T. Johnson, and Dr. R. Nagarathinan, HOD in charge of Phase 2 Campus, who is constant support for arrangement in this event. Thank you, sir. Thank you, ma'am. I wish to thank my colleagues, Professor Viola, Professor Srisha, Professor Finil Zobila, Professor Nadini Devi, who is taking care of registration, circulation of our event. Thank you, ma'am. Without technical support, this event won't be happened. I thank Professor Srisha and our system admin, Mr. Ganesh Babu, who is our technical support. Thank you, sir. Thank you, ma'am. I wish to thank all participants from all over the world for attending the workshop. Last but not least, I pride to thank my entire team of all the arrangement made. Hope you all will have a fruitful experience with some key takeaway at the end of the workshop. Thank you all. Thank you.
Thank you so much, sir. Dear participants, the feedback form is available in YouTube description box. You are requested to complete and submit the form before 10 p.m. today. Later, the form will be deactivated. The e-certificate for participation will be sent to registered email IDs within 3 working days. As per our policy, we normally won't request speakers to send their PPT, but same time, this video will be ever available in our YouTube channel. Participants can view at any moment. We came to an end of the program. Hope everyone has gained the knowledge. With the satisfaction of presenting a good e-workshop, we wish to sign off and meet you in the next program. Don't forget to submit your feedback form and subscribe our YouTube channel, Dr.M.G.R. University Phase 2 Digital Learning, for further updates about our programs and videos. Till that, stay home, stay safe, stay healthy. Thank you.
Dr.M.G.R.Educational and Research Institute, University, Madurai, Chennai.